Hello everyone, this is Balaji.K.R signing in for Brain Smart Labs. And you know what I will be teaching today? It's Building Block No. 5, Data Types. Before starting with the next topic, let us take a quick recap on what we did in our previous session. In our previous session, Java as a language, we saw step-by-step process of performing addition operation in Java using a user-friendly editor by name Edit+. We saw the equal to symbol in a Java program acts as an assignment operator which copies and transfers the value from RHS to LHS. We understood the concept of single line and multi-line comments in Java, wherein we came to know that the comments in our source code are neglected by the compiler while generating the bytecode. This process of hiding things from the compiler is known as deceiving the compiler. In our next topic, we saw step-by-step process of performing string concatenation in Java. Followed by an introduction towards building blocks of programming, we took an overview of few of the building blocks like character set, keywords, identifiers and variables. We had also instructed you to perform some mini assignments before entering the next class. Hope you have done it. If not, muchkond code madi. In our today's class, we will try to understand the concept behind data types. If you ask me what is a data type, well, a data type is a placeholder on which your data sits. Every time we declare a variable, first we declare its type. Based on the type of data declared, our JVM allocates, aka reserves certain amount of memory to store our values inside. The amount of memory reserved depends on the type of data declared. You will understand this better as you see more examples today. But before we get there, let us take a quick look on various data types present in Java. Data types in Java can be differentiated into three types. That is A. Primitive types which include byte, short, int, long, float, double, char and boolean. B. Derived types which include arrays. And C. User-defined types which include class, subclass, abstract class, interface, enumeration and annotations. I know you are familiar with few of the primitive data types like int and float. Well, whatever it might be, keep everything aside and start seeing everything from scratch. The problem with you guys is you will learn only Anpa Solpa in college, but when I try to teach you in detail, you try to skip the class thinking that you know everything. What you know everything, name Pinda. My question is, if you know everything, why are you watching this video in the first place? You all are big Brahaspatis, no? Go and attend the interview directly. Narayan Murthy and Menkot Mava, you'll be waiting with a cubicle ready for you. Why are you wasting my time over here? Nettic basics kaliyak wakilla, skip the video, skip. Remember, the video I am making is not for the student who thinks I know everything. Even a below average student should understand every concept what I teach over here. That's my basic agenda. Na paata madade hinge. Ellaru ನನ್ನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಷ್ಟ ಇದ್ರೆ ಕೂತ್ಕೊಳ್ಳಿ, ಕಷ್ಟ ಆದ್ರೆ ಎದ್ದಡಿರಿ, ಯಾವನ ಹಿಡಿದಿಟ್ಕೊಂಡಿರೋದು ನಿಮ್ಮನ್ನ. But one thing you keep in mind, without learning basics, if you directly skip to advanced, ಬಗ್ನಿ ಕೂಟ ಅಂದ್ರೆ ಕೇಳಿದೀರಾ? ಬರೀ ಕೇಳೋದಲ್ಲ, ಫೀಲ್ ಮಾಡ್ತೀರಾ.
Classification of primitive data types.
Let us start seeing one by one how primitive data types are classified in Java. Note down this tree diagram as it is very important for your interview. Primitive data types are basically classified into two types. A. Numerical data types and B. Non-numerical data types. The data type which can hold numerical values are known as numerical data types. If a number has to be stored inside a variable, it must and should be of numerical data types in nature. Based on the types of numbers stored inside, numerical data types are classified as A. Integer types which can hold only whole number values, and B. Floating point types which can hold fractional numbers, aka your decimal point values. The data types that fall under whole number category are byte of size 8-bit, short of size 16-bit, int of size 32-bit, and long which is of size 64-bit. The data types that fall under decimal point category are float of size 32-bit and double of size 64-bit. In non-numeric data types, we have a data type by name Char, which can hold only one character and it is of size 8-bit. Last but not the least, we have a boolean data type which can hold either value true or false. The above tree diagram contains a detailed classification of primitive data types. In your interview, they might ask, name the 8 primitive data types in Java, for which your answer should be byte, short, int, long, float, double, char and boolean. Dude, why do you always refer it as primitive data types? What is so primitive about it? That's because before Java came into existence, we had languages like C and C++ that had incorporated all of the above 8 data types. As founders of Java retained this in their language, they classified the above 8 data types as primitive data types. Most of the concepts which are present in C and C++ were incorporated in Java as they were very user-friendly.
Oh, really?
Java became a hit among developers because during those days, if you knew how to program in C, it was very easy for you to get adjusted to Java. As C language was a hit during early 90s, many developers migrated towards Java as it was no different to code compared to C. Many other languages like COBOL, Ruby, etc. didn't shine among developers as these languages had syntax way more different compared to your C syntax. Java became more popular among developers as it followed C syntax. Got it?
Yes!
Wow! I didn't know this story. Thanks for telling. Can you now teach me how these primitive data types can be used in our program? There you go.
Working with primitive data types.
In My Computer window, go to D drive and then go on to Workspace. Go inside Basic Examples folder, inside which we will create our new folder 02 Data Types. Inside 02 Data Types, create a new Java file by name datatypesdemo.java using the techniques I have showed you in my previous sessions. Open the file using Edit plus Editor and start typing our new program, that is class space datatypesdemo. Please note that the class name what we have typed over here must be same name as our source code file name. Open and close the flower braces and in line number 3, start typing the code public public, static static, void void, main main, followed by string args in small parentheses. Enclose the main method with flower braces and starting with line number 5, we are going to demonstrate how various data types work in Java. In line number 7, type the statement byte b is equal to 25. Ending every declaration or a statement with a semicolon is mandatory. If not, you will be getting a compilation error. Mind it. The below declared byte variable is of range -128 to +127. That means you can store only values between -128 to +127 as our byte variable is of size 8-bit. Write a SOP statement to display the variable value and compile the program. As you can see, our program has 0 errors, which gives us a clean go ahead to run the program by pressing Ctrl 2. Tada! Hope you can see the variable value 25 getting printed. Please note, the program is working fine because the variable value what we have feeded is in between the byte range -128 to +127. Now if you cross the byte value above the prescribed range, for example 300 and then compile, we will be getting a compilation error by name incompatible types blah blah blah. So it is always advised, always feed the values as per the range prescribed for a data type. Next we have data type by name short, whose values can range from -32,768 to +32,767. Again, as it happened in byte, if you are feeding a value which is crossing the prescribed range for short data type, for example 55,300, you will be getting the same compilation error as shown here. Moving on, let us proceed to a data type by name int, which you are all familiar with as you have used it in your addition program. The range of an integer variable, commonly known as int variable, is very huge as seen over here. However large the prescribed range is, it is always advised not to cross its range whatsoever, else you will be getting a compilation error. So what should we do if we have a 10-digit or 11-digit number to store? This int data type will not be of use then. For our surprise, there are numbers which crosses the range of prescribed int data type 2. And to satisfy this requirement, Java provides us with one more data type by name long, whose range is minus 2 to the power of 63 to plus 2 to the power of 63 minus 1. Please note, while feeding a literal value to a long data type, we need to suffix the letter capital L as shown here. Well, if you don't suffix this capital L, your value will be considered as just another integer value. Be careful. The above numerical types what I just taught, that is byte, short, int and long, fall under the whole number category. In decimal data types, we have a data type by name float, which is of 32-bit and it can hold single precision decimal point number. I can give you a 1-hour lecture on what is single precision decimal point number, but frankly telling, this is not at all required for your programming career. For now, just understand single precision decimal point number means a small fractional decimal point number. That's it. A small floating point value in Java is always denoted by suffixing lowercase f to its original value as shown here. Suffixing capital L to a long value and a small f to a single precision floating point value is compulsory while feeding the values for its variables. The suffix added helps the compiler and the JVM to differentiate these values from the other int and double values respectively. If you tend to miss the prescribed suffixes, you will be getting a compilation error stating incompatible types. Be careful. After seeing the float data type in Java, it is time to meet its bigger brother, double data type, which is of 64-bit in size. A double data type can hold double precision decimal point numbers. As I said before, you need to know only one thing about double precision decimal point numbers. They are very large size fractional numbers. Large. Very large. And that concludes the demonstration for decimal point data types, that is float and double. Now let us start seeing the demonstration for non-numerical data types, starting with our good old data type char. Char data type in Java is used to hold a single character. A character can be of anything what you see on your keyboard. That is alphabets ranging from A to Z, both in lowercase and uppercase, digits ranging from 0 to 9, and all the special symbols as you see on your keyboard. Make sure that your char value is always enclosed with single quotes. Well, if you don't enclose your char in single quotes and your text strings in double quotes, your compiler uncle will slap you on your face with a compilation error. Be careful. Next data type is boolean. The possible values for boolean data type is true or false. That means only true or false. Yeah, only true or false. Interestingly, both are keywords or reserved words in a Java program. True and false values are highly case sensitive in a Java program as they are keywords. So don't try to play a mess using capital T for true and capital F for false, which will ultimately result in, wait for it, compilation error. And that completes the demonstration for primitive data types. Now it's your job to compile the program in each stage and run the same to know how these data types behave all by yourself. The more you work on data types, your roots on basics will grow deeper and nobody can shake you in any interview. Trust me, you will go so strong that if your boss also goes wrong somewhere, you can challenge him that he is wrong and you're right.
Oh, really?
Frankly speaking, your project managers will not be knowing much about a language used in your projects. If you tell wrong also, they will nod their head. If you tell right also, they will nod their head. These people will be so busy with their Excel sheets, at some point of time they will forget head and tail on how to code, as they're only worried about how to extract work from you in that project.
Oh no!
Impressing them will give you some bonus points and helps you gain more reputation in the company. If not for your self-improvement, at least for this reason be strong at your basics. Please. Dude. You taught us different types of numerical values, adalla okay. But crossing of range, compiler error, incompatible types was totally not fair. Is there any other way where we can put big numbers in smaller data types? Yaar helidilla anta? Of course there is a way. It is called typecasting. To learn this, first we have to understand how variable transfer works in Java. Are you ready for it? Innen bajane madaka idiville. Ready. Kelad nodu. Next topic is variable transfer.
Variable transfer between same data types.
Consider a byte variable A and the value assigned to it is 5. Consider another byte variable B, and for now we don't assign any value to it. Whenever we write a statement B is equal to A, the value on RHS flows towards the variable in LHS. As both our variables are of type byte, both are of 8-bit in length. Once the transfer operation is initiated, using the assignment operator equal to symbol, the memory bits towards the right hand side will transfer and copy itself to the memory bits on the left hand side. If you take a closer look, it is the 8 bits of memory location pointed by variable A that is being transferred inside 8 bits of memory location pointed by variable B. The variable transfer here happened very smooth as both the variables are of 8-bit in length. Let us consider one more example by taking int p is equal to 15 and int q is equal to 21. If we initiate the transfer between them by saying q is equal to p, the 32 binary bits present on your RHS will transfer and copy itself onto the 32 binary bits placed on your LHS. Once again over here, the variable transfer happened very smooth as both variables are of 32 bits in length. This is the exact process what will happen when you initiate a variable transfer using assignment operator. All these days you were thinking variables are nothing but boxes that hold numerical values as it is. If so, you're completely wrong. Whenever we say variable A is holding value 11 and variable B is holding value 5, it actually means A is pointing to some memory location 1 which is in return holding the value 11 in binary. Likewise, B is pointing to some memory location 2 which is in return holding the value 05 in binary. Everything on your computer today runs on binary numbers, that is zeros and ones, and so the values that are stored in your memory will also be in zeros and ones. This means values that get stored inside your memory locations are in binary format, although you feed the values in its actual form of decimal numbers. The variable names A and B are just pointers to these memory locations where our value is actually present. For example, byte is of size 8 bits and it can hold values from -128 to +127. Short is of 16 bits in size and it can hold slightly larger values. Likewise, int and float are 32-bit in size, long and double are 64 bits in size. Each bit placement can hold either 0 or 1, which will relate to some value of what it is holding. If you are confused with the binary stuff that is ones and zeros blah blah blah, don't worry. This is just an illustration of what is happening at the back end of your program. You need not worry much about this if you have not studied digital electronics in your college days. This is nowhere connected to your programming skill in Java, so chill.
Understanding primitive typecasting.
Variable sizes can be related to buckets in Java. For example, byte data type is of 8 bits and it is of very small in size. Short data type is slightly bigger than byte as it is of 16 bits in size. Int and float are very large compared to the other two as they are of 32 bits in size. Last but not the least, long and double can be related to extra large buckets as they are of 64 bits in size. Each variable in Java can be termed as a cast or a mold where we hold different sets of ones and zeros to give it a shape. Ultimately, everything in Java is nothing but zeros and ones. If these ones and zeros are present in an int variable, they can be collectively called as an int value. The same ones and zeros if present in a float variable, they can be collectively called as a float value. The example I showed you, that is variable transfer between two byte variables, is an example for variable transfer between two similar data types. Now let us understand what will happen if we transfer two variables which are of different data types in Java.
Variable transfer between different data types.
Consider a variable byte a whose value is equal to 10. Now declare an int variable I whose value is equal to numerical 5. If we transfer the value of byte a inside integer I using the statement I is equal to a, no issues are created even though both are of different data types. The reason being, byte a is of 8-bit and int I is of 32-bit in size. The transfer operation will not create any problem as 8 bits on variable a can be copied easily onto 32 bits on variable I. That's because a bucket of 8-bit can go easily fit inside a bucket of 32-bit without any complication. This phenomenon of transferring values from a smaller bucket to a larger bucket is known as implicit type casting. It means during the variable transfer no additional casting or process is required. Typecasting is a very important topic and I need your full attention over here. If you have not understood the bucket example and what is implicit typecasting, please rewind the video and watch it again. The next topic I am going to teach you is way more complicated and it is terrifying as it sounds. Explicit typecasting. Consider our previous example byte to integer transfer. Here as you can notice, integer variable is on your LHS, byte variable is present on your RHS. What will happen if we interchange them? That is changing the statement to a is equal to I. You mean integer to byte transfer? Integer is of this size, byte is of this size. How on earth we can transfer? You are very much right. As you predicted, you will be getting a compilation error stating incompatible types. Dude, that's really strange. In our previous example also we had variables of different data types. Why didn't we get an error there? Why only here? The answer is simple. If you analyze both LHS and RHS, your RHS is larger compared to LHS where your data bits has to go and sit. If you relate this to a bucket example, the bigger bucket on the right hand side cannot fit inside a smaller bucket on the left hand side. So is there any way in Java to make this fit inside this? Take a look over here. The process I am going to perform now is known as explicit type casting. Now I type the magic phrase over here. Ta-da! That's it. It's just the name of the data type which is to be converted in small parentheses. Katam gatam. Wow! That's it. I thought it is some big process. In implicit typecasting, the bit size of the placeholder present in LHS is always larger compared to RHS. So here, no additional casting was required. Whereas here in this case, the RHS is larger compared to LHS and it needs to be trimmed before transferring the value. External typecasting here means shrinking the size of 32-bit value to fit itself to a small 8-bit variable. Please note, in typecasting only the values get shrinked and transferred but not the variable itself. The variable on the RHS will remain intact throughout the program. Remember, the typecasting process was performed only because value transfer from one variable was not happening as it was not fitting the other variable. Typecasting happens only for the values that get transferred and not for the variables. The variable will remain intact even after the transfer. Got it? There are three things which are to be considered before performing any typecasting operation. They are size of the variable. We always have to know the size of the two variables involved in typecasting. Bit size defined for a data type plays a very important role during typecasting. Range of the variable. Knowing the range of the variable is a very important aspect as typecasting leads to precision loss or data loss during casting of numbers. Types of variables. Primitive typecasting is only possible under numerical data types. That is, casting can only happen between byte, short, int, long, float and double. If we try to typecast other types of data, we will be getting a compilation error. Be careful.
Precision loss or data loss during typecasting.
In this program, as you can see, we have created a float variable with a decimal point value. that is float f is equal to 3.7192f. Below this variable, we have declared one more variable of type int. Casting the float value and transferring it to int will lead to loss of precision, meaning if we compile this code and run the program, the resultant output value of I is just numerical 3. The value 3.719f was trimmed to 0 decimal places using the integer cast applied, and then the trimmed value was transferred to variable I as seen here. One more example of loss of precision can be seen in the example below. The long variable L contains a large 12-digit numerical value. When we typecast this number to an int data type and then transfer it to an integer variable, the 12-digit positive number gets converted to a 9-digit negative value. The converted negative value will no doubt fit the range of an int data type, but it is a tremendous loss of data. This phenomenon of values losing its original identity during typecasting process is known as loss of precision.
Byte arithmetic in Java.
The last thing you need to learn in primitive typecasting is byte arithmetic in Java. Frankly speaking, I have never seen any programmer use this while building real-time applications. But there is always a benefit in learning new things. Learning byte arithmetic will help you to get a better clarity on typecasting process. So what are we waiting for? Let us take a quick look on how byte arithmetic will work in Java. Consider a program where byte A is equal to 10 is the first operand and byte B is equal to 15 is the second operand. Now declare a variable byte C to store the result of this addition operation. Type the code to perform this addition operation, that is C is equal to A plus B. Type an SOP statement to display the result. The code here appears very simple as it is a plain addition program, but it turns out to be really complex the very moment you compile this file. Ta-da! Can you see? You have received a compilation error stating incompatible types in line number 9. Incompatible what? Has compiler gone nuts? Value of variable A is a byte, value of variable B is a byte, sum of these two numbers is 25, which is also a byte as it is in the prescribed byte range. How the hell can the compiler say it is incompatible types? Now please stop yelling at me. There is a strong reason in Java why this happened. If you look closely, the below compilation error says possible lossy conversion from int to byte. This means while performing the addition operation, the byte is getting auto-promoted to int. And because of this reason, while storing the result, the integer value is not fitting as LHS is a byte container. Now imagine, how can a 32-bit bucket go fit inside a 8-bit bucket? Impossible, right? Guru, why did the JVM auto-promote our operand values to integer values in the first place? Haven't we specified that we will be doing a byte addition? Well, the answer is quite complex. So pay your full attention on what I am saying. Founders of Java, while defining a byte, made it as a 8-bit variable which is 100% valid. But to perform any arithmetic operation, it has to happen in your CPU's arithmetical logical unit, which sits directly on top of your operating system. Actually, the real problem lies with the operating systems which has not defined what is a byte in its design. So, the founders of Java decided to promote these values to integers, aka your int data type, which was commonly used in all operating systems then. Whenever we perform arithmetic operation on 2-byte operands, Java implicitly converts it to int data type and asks the operating system to perform addition operation. Okay, JVM promotes the value to int, delegates the operation to arithmetical logical unit, operating system, whatever you call, and we get our result. Now what? How to save the result in our byte C variable? There is only one option. Explicit type casting. Typecast the result back to byte and assign the value to variable C. That's it. Katam gatam. Run the code and you will get the addition result as expected. Congratulations. dude, I might have understood what you are telling, but your other students who are sitting right there might find it very confusing as it is a very tough concept to understand. Can you repeat it one more time for everyone, please? Of course, take a look. Whenever you perform byte arithmetic operation, the JVM has to delegate this operation to your OS, and so your JVM will auto-promote the byte values to integer values. Once it is done, the addition operation happens smoothly and we get an integer value as our result. To store the result from RHS to LHS, it is now impossible, as RHS has a 32-bit integer value and LHS has a 8-bit byte variable as its placeholder. The only solution now is to typecast the integer variable using a byte caster, where the byte caster removes all the excess bits, trims it to 8-bit value and then copies it to the other side as seen here. Okay, time has come for me to wind up this session, but before me winding up, let me repeat certain things as it will be definitely asked in your interviews. Understand typecasting concept very clearly. During variable transfer, when the RHS is small compared to LHS, value present in RHS can fit easily into value present in LHS. This phenomenon is known as implicit typecasting and no external typecasting is required over here. Meanwhile, on the contrary, if the value present to your RHS is larger compared to the variable present to your LHS, the value cannot fit inside the variable present to your LHS. To make it fit, an external cast is required as it will trim the value before sending it to your left hand side. This phenomenon is known as explicit type casting, and this may lead to loss of precision or loss of data compared to the actual value. You can never typecast a non-numerical value to a numerical type or vice versa. Reason is simple. Why on 7 hells you want to convert a character to a number? Why on earth you want to convert a true-false value to an integer? Stupid. As I said before, casting will lead to loss of precision or loss of data. A programmer should forecast his output before typecasting any primitives. If you have not understood the concept of primitive typecasting yet, chill. It happens for the first time. Try seeing the video one more time. Well, if you still don't understand it properly, don't worry. Your experience in programming will teach you better in near future. Before you reach my last class on Core Java, I promise you that you will be a master in typecasting. Trust me, a word given by me is always a word. You can rely on that. But one thing you have to understand in today's class is Java is a strictly type-checked language and you cannot play around with data types. If at all you want to play around, you will be getting a compilation error at the very beginning stage. Many of the primitive computer languages allowed values of any type into variables of any type. Few of the computer languages have only one data type defined, which is common for all. Java is such a robust computer language compared to all, as it does not allow any type mismatch whatsoever. If any mismatches are found, it is reported during compilation stage, while in other computer languages like C, it passes the error onto the runtime with just a warning during compilation. Trust me, it will not only lead to loss of precision or loss of data, it might even lead to system crash if you run such programs. Boom! God only knows. So my dear students, I am teaching you the best programming language in the history of mankind. Pay your full focus and attention while learning, and please make notes for every step as I tell, as making notes is a very important part. Subscribe to this channel and stay updated for our next video release. Till then, this is Balaji.K.R signing out. See you soon. Much code madi.